PQT Anna University question paper, November-December 2018, question number 14B. A petrol pump station has 4 pumps. The service time follows the exponential distribution with a mean of 6 minutes. That means the service rate is 6 minutes. And cars arrive for service in a Poisson process at the rate of 30 cars per hour. The question is, what is the probability that an arrival would have to wait in line? Another question, find the average waiting time in the queue, average time spent in the system, and finally the average number of cars in the system. So these are all questions. So the question is, the petrol pump station has 4 pumps. That means multi-server. There are 4 servers available for service. So multi-server and capacity of the system not mentioning here. So that this is infinite capacity. So this is a model, second model, multi-server infinite capacity. So this is a problem in, this is model 2, multi-server infinite capacity. So MMS infinite system and first in first out. So this is model 2 because there are 4 servers for service, so that multi-server, and the capacity of the system is not mentioning here, so that infinite capacity. So this is model 2, and the service rate is given by 6 minutes, so that mu is equal to 6 minutes. But I want to convert it into per minute number of customers, so that this is converting to 1/6 per minute. And the arrival rate, the cars arrive for the service in the Poisson process at the rate of 30 cars per hour. So lambda is given by 30 per hour. 30 per hour. But this unit is, service unit is in minute, but here is per hour, in hour. So this per hour I want to convert into per minute. So that divided by 60. So that 30 by 60 per minute. So by cancelling this, 1/2 per minute. So both are is in minute. So we are converted into both are in minute. So we form lambda and mu. Now these are all required formula for this model. Rho is equal to lambda by mu s, where s is the number of server. P0 is the sigma n equal to 0 to s minus 1, s rho the whole power n by n factorial plus s rho the whole power s by s factorial into 1 minus rho whole power minus 1. This is the formula for P0. And LQ is number of customers in the queue, 1 by s into s factorial into s rho the whole power s plus 1 by 1 minus rho the whole power 2 into P0. And LS is number of customers in the system, is equal to LQ plus S rho. And WQ, this is waiting time of a customer in the queue, is LQ by lambda. And WS, waiting time of a customer in the system, is LS by lambda. And another one, this is the probability that an arrival has to wait for service. It is a formula P of n greater than or equal to S is S rho the whole power S by S factorial into 1 minus rho into P0. So these are all required formula for this model. So now here, so from the given data I am going to find rho. So rho is lambda by mu s, but we found lambda is 1/2. So this is 1/2 whole divided by mu. Mu also given by 1/6 into s. S is number of server. There are 4 servers. There are 4 pumps are available. So it is 4. So now here 1/2 whole divided by 4/6. It is 1/2 into 6/4. simplify, this is 3 by 4. This is 3 by 4. So finally this can be simplified. So rho is equal to 3 by 4 is 0.75. So this is rho. And now for convenient I am going to find S rho. S rho is, S value is 4, rho value is 0.7, or you can take 3 by 4. So this is 3 by 4. Cancel 4, we get 3. So that S rho value is 3. Okay, now for the all value we want P0. So that next I am going to find P0. This is the formula. So in this formula I am going to substitute all the value. S rho we found 3 and rho 0.75. So substituting all the values here. So now P0. P0 is equal to sigma n equal to 0 to S minus 1. S is 4. 4 minus 1 is 3. And into S rho the whole power n. S rho is 3. So S rho the whole power n by n factorial plus S rho the whole power s. S rho is 3. Whole power s is 4 by s factorial. So 4 factorial into 1 minus rho. Rho is 0.75 into whole power minus 1. Okay. So now I am going to simplify. So now put n equal to 0. N equal to 0 mean anything power 0 is 1. 0 factorial is 1. So that when you put n equal to 0, it is 1. And next put n equal to 1. Put n equal to 1. 3 power 1 by 1 factorial. 3 power 1 by 1 factorial is 3. And now next plus put n equal to 2. 3 power 2. 3 power 2 is 9. So 9 by 2. And put n equal to 3. 3 power 3 plus 3 power 3 by 3 factorial. And last here 3 power 4 by 4 factorial into this. So this is 4 factorial into 1 minus 0.75 is 0.25. 0.25. So this is whole power minus 1. So now using calculator I am going to simplify. This is 1. 3 by 1 is 3. 9 by 2 is 4.5 plus 3 power 3 by 3. 3 power 3 by 3 solved by using calculator, you will be getting again 4.5, and use your calculator, you will be getting 13.5 whole power minus 1. So add all the value, you will be getting 26.5 whole power minus 1. So take your, using your calculator, 26.5 power minus 1 value is 0.0377. So this is the P0 value. So we found the P0 value. P0 value is 0.0377. So this is P0 value. Okay, first question is, what is the probability that an arrival would have to wait in line? So formula is, the probability that an arrival has to wait, the formula is P of n greater than or equal to s is s rho power s by s factorial into 1 minus rho into P0. This is a formula. So I am going to substitute all the value. So here P of n greater than or equal to s. So n greater than or equal to s is 4. There are 4 pumps. S rho power s. S rho we found 3. S rho power s by s factorial into 1 minus rho. Rho already we found 0.75. So 0.75 into P0. P0 already we found the P0 value is 0.0377. So now I am going to simplify using calculator. 3 power 4 into 0.0377 value is 3.0537 whole divided by denominator 4 factorial into 1 minus 0.75. The value is 6. So dividing these two, you will be getting 0.509. So this is the probability value that an arrival has to wait in the line. Second question is, find the average waiting time of a customer in the queue. That means we want to find out waiting time of the customer in the queue is WQ. We want to find out WQ. The formula for WQ is LQ by lambda. So first we have to find out LQ. This is the formula for LQ. LQ is 1 by S into S factorial into S rho power S plus 1 by 1 minus rho power 2 into P0. So first I am going to find LQ. By using LQ, I am going to find WQ. So LQ formula. So LQ is equal to 1 by S into S factorial. S is 4 into S factorial. 4 factorial into S rho the whole power S plus 1. S rho is 3, already we found. S rho power S plus 1. 4 plus 1 is 5, whole divided by 1 minus rho. Rho value is 0.75 power 2 into P0. Already we found P0 value 0.0377. So now using our calculator, 3 power 5 into 0.0377 value is, it is 9.1611 whole divided by, again in the denominator 4 into 4 factorial into 1 minus 0.75 the whole square. By using calculator you will be getting 6. So divide these two, you will be getting 1.5269. So this is the value for LQ. But we want WQ. WQ formula is, WQ is LQ by lambda. LQ value is 1.5269 whole divided by lambda value is 1 by 2. So 1 by 2 means, you take in the numerator 2 into this. So using your calculator, multiply with 2, 1.5269. The value is 3.05. So 3.05 minutes. So customer waiting time in the queue is 3.05 minutes. So next we want to find out customer waiting time in the system. That means average time customer spend in the system. So this is the W, waiting time of the customer in the system. So WS, we want to find out WS. The formula for WS is LS by lambda. So to find WS, we want to find out LS by lambda. But LS we want to calculate by using the formula. LS is LQ plus S rho. So first I am going to find LS. LS is, we want to find LQ plus S rho. But LQ already we found. LQ value is 1.5269. So this is 1.5269 plus S rho. S rho already we found, it is 3. So adding these two, you will be getting 4.5269. So this is the value for LS. But we want to find out WS. The formula for WS is equal to LS by lambda. So LS we found 4.5269 divided by lambda value is 1 by 2. So denominator and numerator multiply with 2 here, we will get 9.05. So customer waiting time in the system is 9.05 minutes. So next question is average number of cars in the system. So in this problem, customers is represented by cars. Okay, so average number of customers in this system. So I want to find out LS. So I want to find out LS. So to find LS, we know the formula. The LS formula is LQ plus S rho. But LS already we found. So LS value already we found. The value is 4.5269. So that average number of cars in the system is approximately 4 cars.